So this is the 17th video on friction. In this video also I'll take up a numerical problem on friction. Okay. Now what I'll do, first I'll write down the question, okay, and draw the diagram of the situation. Then I will list out all the different phases in which I'll solve the problem, and then actually finally I'll solve the given problem. Okay. So first what I'll do, I write down the question along with the given diagram. Okay. So consider the diagram shown below, in which all the details are given. Okay. I'll draw the detail of the situation here. Okay, fine. All right. So what we are given is this. There is a wedge. Okay. There is a wedge whose inclined face makes an angle of alpha with the horizontal. Okay. This is the wedge. Okay, fine. Mass of wedge is given to be 3m. This wedge is placed over a smooth horizontal surface which is taken to be the xy plane. X-axis is this, y-axis is this, so z-axis is vertically upward. I hope you understand what I am saying here. XY plane is the horizontal xy plane. Okay. This axis side, one side of wedge is y-axis, this is x-axis, this origin, this z-axis upward direction. This is a smooth horizontal surface. Okay. In 3D view it is like this, actual like this, x is this, y is this, z is upward. Okay. This is the rough inclined face of the wedge. There a block of mass m is placed here, and friction coefficient mu between block and the wedge is mu is equal to tan alpha. Okay, fine. Friction coefficient mu between block and the wedge is how much? 2 tan alpha. This wedge is free to move over a smooth horizontal surface, and this horizontal surface is taken to be the xy plane. Alright, entire system is initially at rest. Now a constant horizontal force F is applied to this vertical triangular face of the wedge in opposite to x direction. That is, this force F is up in horizontal direction opposite to x-axis, that is along negative x direction, and is right angles to this vertical triangular face of wedge. Okay. Now question is, what is F max? What is F max? That is maximum value of F. Okay. So that block does not slip with respect to the wedge. Block does not slip with respect to the wedge. That is the question. Okay. F max meaning maximum value of F. So we have to determine the maximum possible value of F so that the block does not slip with respect to the wedge. So what is that maximum possible value of F? Capital F. Okay. This we have to determine. Answer should be in terms of m, n, g and alpha. Okay. G is acceleration due to gravity. Alright. Fine. So I will rub this one. So now what I do, now what I do, see how I will solve the problem. So now the starting point is most crucial. Okay. The first of what I do, see what I am saying, going to say first. See, when I apply a force F to this vertical triangular face of wedge, this force F in negative x direction, then because of this force F, this wedge will accelerate in negative x direction with some acceleration a with respect to ground. Okay. So let a be the acceleration of wedge with respect to ground. Okay. This a will be in negative x direction, just in the direction of the externally applied horizontal force F, capital F. Okay, fine. Now this means that this wedge is a translating non-inertial reference frame. Okay, wedge is a translating non-inertial reference frame. Okay, now what should be our approach? See, we have been asked to find out the maximum value of capital F so that the block does not slip with respect to the wedge. So what should be our fundamental approach? Our approach should be find two things. First, what? F and N. Where small f is what? Friction force on the block due to wedge. And what is normal force? N. Normal force on the block due to wedge incline. We find this F and N using laws of motion, and it is given that the block does not slip with respect to the wedge. So for no slip, F should be less than equal to un. So our fundamental approach should be to find F, to find capital N, and apply this inequality, F less than equal to un, for no slip between the block and the inclined face of the wedge. Alright. Now we have to find this F, we have to find this N. Alright. Now I rub this one, okay. Now to find F and N, what I do, I draw the free body of this block with respect to wedge. So FBD of block with respect to wedge. FBD of block with respect to wedge W. Now as I've said, wedge W is a translating non-inertial reference frame. So as seen from wedge, real forces and pseudo forces will act on the block. Okay. So I'll take the block here, I'll draw its FBD in three dimension. Okay. So one force is its weight mg downward direction. That's the real force. So the normal force, there will be a normal force on the block due to wedge incline, which will be normal to the wedge incline. Something like this. N. Okay, fine. Now direction of friction, that is not yet known. See, sometimes it happens that when we solve a problem, direction of friction is not known in advance. So what you do, you skip that part and draw the remaining forces whose direction is known. Now we are drawing the FBD of block in the frame of wedge, and the wedge is a translating NIRF. So as seen from wedge, a pseudo force will act on this block in direction opposite to this acceleration A, which I mentioned just now. Okay, so pseudo force will act on the block in direction opposite to vector A, small a. That is in direction opposite to F. So pseudo force will act on this MA. This pseudo force MA will be in negative x direction, along positive x direction. This pseudo force will be opposite to the direction of acceleration of wedge with respect to ground. With respect to ground, wedge is accelerating along negative x direction. So pseudo force on the block as seen from wedge will be MA in positive x direction. Okay, fine, alright. Now I'll just show this algebra now, okay. See, for the sake of clarity, what I do, I show these forces in this diagram itself. This will be more clear, okay. So see, what are the forces on block as seen from wedge? Mg, normal force is this, at right angle to the wedge incline. There is a pseudo force on the block as seen from wedge, which is in positive x direction. Okay, so these are the forces. And friction force I have not yet shown. Now friction force, how do you determine? See, component of mg along the incline will be what? Mg sin alpha down the incline. I hope it is clear. Mg has a component along the incline, which is mg sin alpha down the incline. And there is a component of normal force on the block due to wedge incline, which is in this way. And mg, component of mg normal to incline is this one. How much? Mg cos alpha. Alright, fine. So now see. So now we can now determine the value of f. See, it is required that the block should not slip with respect to the wedge incline. It should not slip with respect to the wedge incline. So this means acceleration of block with respect to wedge incline should be 0. That means net force on the block with respect to wedge incline should be 0. Now for net force to become 0, Ma, mg sin alpha, they should be cancelled out. Okay, so Ma, mg cos alpha, mg sin alpha and friction, they should all cancel each other. So there should be one friction which balances this pseudo force. So there should be one friction force F1 on the block. That is along negative x direction, this one, opposite to Ma, that is along A. And there should be one friction force which just cancels this mg sin alpha, this one. I hope it is clear. So two frictional forces act on the block due to wedge incline. One F1 which just balances Ma, just nullifies it, and this F2 which just cancels out this Ng sin alpha. If F2 cancels this and F1 cancels this, the net force on the block due to wedge will be 0. So acceleration of block with respect to wedge will be 0. That is, the block will not slip with respect to the wedge. Fine. So net friction on the block due to wedge will be the vector sum of this F1 and F2. And angle between F1 and F2 will be 90 degree. You can see from the diagram itself. Alright. So net friction on the block due to wedge will be root under F1 square plus F2 square. I hope it is clear. Fine. I love this one, okay? Now to find F, we must know F1, F2. Now how to find F1? Then F1 and Ma should cancel each other, because with respect to wedge the block is static. So this means if we apply Newton's second law to block with respect to wedge in this direction along x-axis, then what do we write? Mg minus F1 is equals to mass times acceleration of block with respect to wedge in x direction, which is simply 0. Why 0? Because as per the given question, the block is not slipping with respect to wedge. So acceleration of block with respect to wedge along x-axis should be 0. M into 0 becomes 0. So Ma minus F1 is 0. So F1 becomes how much? Ma. Alright. Now we have to know F, we must know F2. Now how to know F2? For that what I do, I apply Newton's second law to block with respect to wedge down the incline. So what do I write? Mg sin alpha minus F2 is equals to M into what? Acceleration of block with respect to wedge down the incline, which is again 0. Why 0? Because with respect to the wedge the block does not slip. So acceleration of block with respect to wedge down the incline is also 0. So M into 0 becomes 0. So Mg sin alpha minus F2 is 0. So F2 is how much? Mg sin alpha. So F2 also has been determined. F1 also has been determined. So they substitute F here. So F becomes how much? Root under Ma whole square plus Mg sin alpha whole square. Okay, fine. Now what you have to see, to know F you must know A. A has to be known. Alright. Now A has not yet been determined. Now A will be determined using the combined equation of motion concept. So I'll use that first. But before, what I'll do, I find this normal reaction N. Okay. Now what is the normal force N on the block due to wedge? See, I apply Newton's second law to block with respect to wedge in this direction, along direction of N. So what do I get? Only force in along the line of motion of N are N and Mg cos alpha. And remaining forces are at right angles, so they have no component. Fine. So what do we write? N minus Mg cos alpha is equals to N times what? Acceleration of block with respect to wedge in direction of N, in a direction normal to the inclined face of wedge, which is 0. Because with respect to wedge the block is motionless. So acceleration of block with respect to wedge in direction of N, normal force N, is 0. So M into 0 becomes what? 0. So N minus Mg cos alpha is 0. N becomes what? Mg cos alpha. Okay. So N becomes how much? Mg cos alpha. Fine. So now what is our aim? Our aim is to find F is less than equal to mu N. So N we have already determined. To determine F, we must only know this value of A. Once A is known, then I substitute in this equation and then the problem will be solved. Okay, fine. So what I do, rub it here, fine, alright. So what I do, first I get the inequality for A from this equation, okay. So F is this much, N is this much, mu is equal to 2 tan alpha. I substitute F and N in this equation, F less than equal to mu N. So what do I write? N becomes common outside. Root under A square plus G sin alpha whole square is less than equal to mu is equal to 2 tan alpha. And N is how much? Mg cos alpha. Alright. Now mm will go away. Fine. So how much it becomes? Root under A square plus G sin alpha whole square is less than equal to 2 tan alpha into G cos alpha. But tan alpha into cos alpha from trigonometry is known to be sin alpha. So this becomes 2G sin alpha. I hope it is clear how it is obtained. tan alpha is sin alpha by cos alpha, cos alpha, cos alpha cancels out, sin alpha remains, the 2g sin alpha. Okay, I rub this one. Okay, I'll square this equation on both sides. G square 4g square sin square alpha. A square becomes less than equal to 3g square sin square alpha. Alright, fine. Now take the square root. So a becomes less than root 3g into sin alpha. Okay, so a is less than equal to how much? Root 3g sin alpha. So in order that the block does not slip with respect to wedge, acceleration a of wedge with respect to ground should be less than equal to root 3g sin alpha. But we are told to find the maximum value of capital F, not a. So a has to be written down in terms of f. Okay. Now to do that, what we have to do? For that, what I will do, I write down the combined equation of motion of block plus wedge in negative x direction. Okay, fine. Now I'll rub this. Okay, this I'll let it remain. Remaining I'll rub it. Okay. So see, in order to determine this A, as I said just now, I write down the combined equation of motion of block plus wedge along negative x direction. Now in combined equation of motion, we have to take several things we have to state first of all. First of all, combined equation of motion, when we are writing combined equation, we have to write down specify the system. So our system is this: wedge plus block. Wedge meaning this triangular block of mass 3m, and block of mass n. This is the system. Okay. Now, when you write down the combined equation, which is we write it with respect to ground, so only real external forces act on the system of this wedge plus block. Only real external forces act on wedge plus block. Now to know what are the external force and what are the internal force, what I'll do, I'll write down the real forces acting on block and wedge separately. Okay, fine. So see, I'll write it here. A will be written here. A is less than equal to root 3g sin alpha. Okay, this I'll use, so I'll write it here. So now I'll list out the forces acting on the block, all the real forces. See, because combined equation is written with respect to ground, as seen from ground, only real forces will act, no pseudo force. So I list out all the forces acting on the block and on the wedge, all the real forces. This is a block. One real force is mg, other is normal force n, other is some friction force, okay, whose resultant will be along f1, f2 something this direction. This friction also I have shown here arbitrarily. And there is also a pseudo force. No, sorry, that's all. These are no pseudo force, sorry. So these are the three forces on the block: mg, f, and n. Okay, this free body I have drawn with respect to ground. Now I write down the list of the forces acting on the wedge. So what are the forces on the wedge? See, one is its weight 3 mg, which is in downward direction. Other is normal force n1 due to ground on the wedge, which is in vertically upward direction, that is along z direction. Then this force F, which is being applied to the vertical triangular face of block F, that's also a real force on the block wedge. Then there is also a friction force on the block due to wedge, just opposite to this F, Newton's third law. And then there is also a normal force on the wedge due to block, opposite to this N, Newton's third law. Okay, fine. So these are the forces. So what are the real forces on the block? mg, f, and n. And what are the real forces acting on the wedge? 3 mg downward direction, n1 due to ground on the horizontal base of the wedge in upward direction, z axis, f horizontal force F on the vertical face of the triangular face of block along negative x direction, and F and N friction force on the wedge due to block, Newton's third law, and N normal force on the wedge due to block, Newton's third law. These are the forces. Fine, alright. Now I wrap this one, okay. Now, as I've said just now, only real external forces appear in the combined equation. In the combined equation of motion, only real external forces appear. Now, in this we have to determine out of these forces, which are the internal forces, which are the external forces. Now, what are internal forces? Forces which various parts of system exert on each other. They are the internal force. Now, see, in these two forces, which are the internal forces? This F and this F, they are a pair of internal forces, because the force exerted between friction force between block and wedge, that's internal to the system, wedge plus block. These two forces won't appear in the combined equation. Then this normal force and this normal force, they are also internal force for the system, wedge plus block. They will also not appear in the combined equation. Then this F and this F and this F, they are already stated. Okay. So remaining force is the external. This mg is force on the block due to ground, that's surrounding exerting external force. 3 mg, ground is exerting gravitational force on the wedge in downward direction, 3 mg external force. N1, normal force on the horizontal base of the wedge due to the ground, that's upward direction z axis, along z axis, that's also an external force. And horizontal force capital F on the vertical inclined face of wedge in negative x direction, that's also an external force. So these are the only external forces, this one, and this one. So these are the only external forces. These are the only external forces on the system of wedge plus block. One is what? Mg in downward direction. Other is what? 3 mg in downward direction. Other is what? Normal force N1 on the horizontal base of wedge due to ground, N1. Then, and there is a force F, 3D view. Force F applied on the vertical triangular face of wedge in negative x direction. These are the only external forces on the system. Okay, only these forces appear in the combined equation. Now we are writing on the combined equation of negative x direction. Along this negative x direction, N1, 3 mg and mg do not have any component. They are in vertical direction. Only force in negative x direction is this one, F. So only external force on the system wedge plus block in negative x direction is this much, F. That is equals to mass times acceleration of the wedge and mass times acceleration of block. All acceleration has to be taken with respect to ground. That is in the frame in which we are applying the Newton's second law. So what do you write? 3m times a, because acceleration of wedge with respect to ground is a, 3ma, plus m times acceleration of block with respect to ground in negative x direction. That is also just a. Why? Because with respect to wedge the block does not move. Acceleration of block with respect to wedge is 0. So acceleration of block with respect to ground is also that of a. I hope it is clear. So F becomes how much? 4ma. This means A is what? F by 4m. Okay. But A should be less than or equal to this quantity. This should be less than or equal to root 3g into sine alpha. So F should be less than or equal to 4m, multiply, cross multiply. So 4 root 3 mg into sine alpha. So this is the maximum possible value of force applied F max. So that the block does not slip with respect to the wedge. So in order that the block does not slip with respect to wedge, maximum value of applied force capital F should be 4 root 3 mg sine alpha, and that is therefore the required answer. Fine, alright. So I hope it is clear. I fully explained it in complete details. You go through it properly. In case you have some doubt, put your doubt in the comment box. I'll look into it, I'll explain it. Okay, so this I close it here. Fine.